Hello students, hello learners, good evening to everyone. So today we are going to have a discussion on operating systems related PYQs in connection with this ISRO examination. So first of all, I want to welcome you all to the ACE Engineering Academy as well as ACE Online. So our motive is, as you know that if you are an aspirant of ACE, if you are an aspirant of ISRO examination, ACE Engineering Academy is supporting you in terms of providing some PYQ series. So today I am here to have a discussion about the previous year ISRO questions in connection with this operating system subject. So before going to see those previous year ISRO questions in connection with this 2023, right? So first of all, you check the weightage of all these subjects. So among these subjects, if you verify operating system which is having highest weightage, which is having 137 questions according to the previous papers from 2007 to 2023, if you can verify, you can find that there are 137 questions are there, and which is the most priority, or else you can say most most weightage. After that you can have computer networks, right? So as it is having more weightage, let us see what is the weightage of this 2023 with respect to with respect to 2023 examination. From operating system, what is the weightage you have? 9 questions. So number of questions that you have in 2023 ISRO previous year paper, from operating system you have 9 questions. So those questions we are going to see, but before that, weightage, if you can see that syllabus of operating system. So basically operating system syllabus is majorly 4 main topics. What are the 4 main topics? One is introduction to operating system, other one is process management, other one is memory management, and other one is file systems, right? So, and if you check here, out of 137 questions, 6 questions are from just introduction to operating system, but verify 74 questions are from process management, which is more than 50%. And from memory management, closely we are having 50 questions, like 49 questions are there. And from file systems, we are having 8 questions. So this is what the number of questions per topic we are having in our previous papers in connection with this operating system subject. So by considering that, you can verify 54% of the weightage is there for process management. And here the meaning of process management is, that we cover this process management usually in our academics, like in our training process, we used to cover this process management in terms of 3 topics, right? 3 subtopics. What are the 3 subtopics? One is process management part 1, another one is process management part 2, and other one is process management part 3, right? So among these 3, from process management part 3, you are having a concept called deadlocks. I hope you are all remember it, right? Deadlocks. So deadlocks concept. So from deadlocks concept, you are having so many previous year ISRO questions. And mind that all the questions whichever we have in our ISRO paper, 90%, I am telling you, out of 100%, 90% questions are our previous year GATE questions. Most of the questions are from previous year GATE papers only, as it is questions we have in ISRO paper also. So as per my analysis of the previous year papers, most of the questions in the process management are from deadlocks. And then the next weightage is to the semaphores. You know that as part of process management part 3, we usually discuss inter-process synchronization. In the inter-process synchronization, we are having one of the topic called semaphores, which is OS based solution to the critical section problem. So based on that also, we are having decent number of questions in our ISRO previous year papers. And as usual, as part of this process management part 2, we are having process scheduling algorithms. You all know that, right? Process scheduling algorithms. So from this process scheduling algorithms, we are having decent number of questions in our previous ISRO papers. And along with this process scheduling algorithms, we are also having another concept called threads. So from threads concept also, we are having decent number of questions as part of our ISRO PYQs. And process management part 1, from here, you know that we are having one concept called process state diagram, right? Process state diagram, like 5-state diagram, 7-state diagram, we have discussed in our regular classes, right? In our training classes. So in those, from that particular process state diagram, especially from 5-state diagram of a process. So from that we have PYQs in our ISRO examination. So these are the topics that you have to more focus from process management. And of course, there is one more topic I forgot, which is operations on a process. Operations on a process. Like you all know that fork, right? Fork system call. So related to this fork system call also, we are having decent number of questions as part of our ISRO papers. Okay. So these are the topics that you need to focus from process management. Then the next weightage, if you can check, it is going to memory management. So verify, as part of the memory management, we are having the probability of 36%. So overall we have 36% of questions from memory management. And from memory management, what are the topics that we need to focus? We need to focus on partition allocation techniques. We need to focus on partition allocation techniques. You know that. What are the partition allocation techniques? Like first fit, best fit, next fit, right? Worst fit. These things we need to focus. Plus contiguous memory, as part of non-contiguous memory management techniques, we need to focus on paging concept, as well as we need to focus on segmentation, right? We need to focus on segmentation. Plus, as part of memory management part 2, as part of memory management part 2, we are having demand paging concept. We are having page replacement algorithms. Several number of previous year ISRO questions are there based on these topics from memory management. So page replacement algorithms, right? As well as, so these are the major subtopics that we need to focus from this memory management. Then when it comes to the file systems, so as part of the file systems, we need to mostly focus on disk scheduling algorithms. Disk scheduling algorithms. You know what are the disk scheduling algorithms that we are having, such as FCFS, right? SSTF, scan, CScan, look, CLOOK, these kind of questions. I mean, based on these algorithms, we are having previous year questions in ISRO examination. Then from introduction, you know that the major important concept is types of operating systems. Like we discussed in our training classes, batch operating system, multi-programmed operating system, multitasking operating system, multi-processor systems, real-time systems. So such type of systems that we have seen, from them we are having questions as part of introduction to operating system. So these are the topics that you need to focus from every main topic of these 4. From introduction, you need to focus on types of operating system. From process management, you have to focus on all these content like process state diagram, operations on a process, threads, process scheduling algorithms, deadlocks and semaphores. Plus, you know, there is 1 or 2 times of questions are there based on producer consumer problem also. You know, classical examples of inter-process synchronization, right? Producer consumer problem. So based on this also we are having 1 or 2 times of questions. And from memory management, we need to focus on these topics: partition allocation techniques, paging technique, segmentation technique, page replacement algorithms and demand paging. And for file systems, disk scheduling algorithms. So this is what you know, most important concepts of operating system in connection with ISRO examination. So I hope you got the clarity on which topics you need to focus in connection with this operating system when you are preparing or else when you are going to appear for ISRO examination. Okay, right. So let's move to the 2023 ISRO questions one by one. As part of that, the first question is this one, which is related to your process scheduling, right? So please verify if you are online or if you are part of live session, try to match list 1 and list 2 and let me know what is the answer for this question. I am giving you 1 minute of time because most of the questions, and I am also telling you that most of the questions are theory based questions from this operating system in ISRO examination according to the previous history. So theory based questions are not going to take much time, right? So please try to solve this question within 1 minute. It would be great, right? Because we are all already preparing the GATE examination. So GATE examination preparation is enough to appear or else to prepare for ISRO examination. So what is the answer for this question? If you are able to answer to this question, please give your key in the comment section or else live chat. So we are having something like process scheduler type and activity is there, right? So long-term scheduler, medium-term scheduler and short-term scheduler, and it is executing much faster, reduces the wastage of the CPU time, controls the degree of multiprogramming and is associated with this swapping. So what is the answer for this question? Great. So if you can check here, long-term scheduler, first of all you check with the long-term scheduler, the correct matching to the long-term scheduler is what? It controls the degree of multiprogramming. You know that long-term scheduler is working between the new state and ready state. It is bringing the processes from secondary memory to main memory. So whenever it is trying to bring more number of processes into the ready state, then you can say degree of multiprogramming is high. Whenever it is bringing less number of processes into the ready state, then you can say the degree of multiprogramming is low, which means overall you can say it can able to do higher degree multiprogramming or else lower degree multiprogramming. So means completely it is having control on the degree of multiprogramming. So the correct matching is 1 goes to Q. So 1Q if you can verify. So based on that you can decide the answer here. 1Q, right? 1Q. Here option A 1 is given R, which is wrong. Option C it is given 1P, which is wrong, right? Then coming to 1R, which is option D, which is also wrong. So what is the answer for this question? Straight away you can say option B, 1Q. Then medium term scheduler. You know that medium term scheduler is also called as swapper, right? It is also called as swapper and it is responsible to do both swap in and swap out operations. So it is associated with swapping. So 2R, yes, 1Q, 2R. Then what else remaining? Short term scheduler. Short term scheduler actually it is intended for making the CPU always busy, means it is reducing the wastage of the CPU time. Yes, so that is the way. By making the CPU busy, it is reducing or else it is nullifying the idle time of the CPU. So that is the way you can match this third one with P. So overall, this is what the perfect answer for this question. I hope you got it right. Next, coming to next question. So please check this question, let me know what is the answer for this question. Which of the following multi-threading model is followed in Linux operating system? So based on the threads concept, it is the question based on threads. Try to answer to this question, what is the answer? If you are in live, please try to answer to this question. So which of the following multi-threading model is followed by Linux operating system? Option A, one user thread mapping to one kernel thread. Option B, many user threads mapping to one kernel thread. Option C, one user thread mapping to many kernel threads. And option D, many user threads mapping to many kernel level threads. So what is the answer for this question? If you can check the multi-threading models, we have discussed in our classes, right? So multi-threading models are three types. What are the three types? One is called one-to-one, another one is called many-to-one, another one is called many-to-many. So here it is clearly mentioned just Linux operating system. So Linux operating system and Windows operating system both are comes under one-to-one relationship, one-to-one model. So one user level thread mapping to one kernel level thread is the correct answer for this question. But if the question is mentioned something like true 64 Linux, this is one kind of operating system, Linux operating system version. If it is mentioned, then it is many-to-many, right? Then it is many-to-many. So true 64 Linux operating system is using many-to-many relationship, right? But it is simply mentioned Linux operating system here. So that is why it is one-to-one relationship. Both Windows operating system and Linux operating system, both are following this one-to-one relationship only. So that is why we can say option A is the answer for this question. Got it? So now we are moving to next question. So look at this question. What is the answer for this question? Please check this question and let me know what is the answer. So the purpose of priority inheritance protocol in synchronization mechanisms is option A, to prevent priority inversion in systems having two priorities for a resource or lesser. Option B, to provide mutual exclusion between the threads and prevent data corruption. Option C, to prevent priority inversion and ensure fairness allocation in resource. And option D, to allow multiple threads to access any resource simultaneously. So what is the answer for this question? Right. So this is related to, it is saying that purpose of priority inheritance protocol to prevent a priority inversion. So basically what is the meaning of priority inversion? That you should understand. So look at. So if you verify, in our classes we used to tell there are three types of locks. What are the three types of locks? One is called live lock, another one is called spin lock, another one is called deadlock, correct? So if you recall those concepts, deadlock, spin lock and live lock, then it is easy to answer to this question. So first of all, you have to understand what is priority inversion problem. So priority inversion problem. So what is this priority inversion problem? If you consider, for example, this is what my ready queue, this is what my ready queue, just assumption, this is what my ready queue, okay, and this is what my CPU, this is what my CPU, okay, and this is what my critical section. You know that according to the process synchronization, as the question is clearly mentioned, in synchronization mechanisms, right? So that's why, you know, according to the synchronization concept, inter-process synchronization concept, a process is being divided into two parts. One is called critical section part, another one is called remainder section part. And according to the critical section problem statement, what is the statement of the, what is the statement? A system contains n number of processes and every process is having its own critical section and remainder section, but the important feature of that system is only one process is allowed to enter into critical section at any point of time. That is what your critical section problem, right? So now look at, assuming that at some point of time, a process PL. So what is the meaning of PL? PL means low priority process. PL means low priority process. So at some point of time, or else initially, or else at time t0, PL is only the process which is part of ready queue. Then to make the CPU busy, obviously we are allocating this PL onto the CPU. Now PL is on the CPU. So it is being scheduled, right? It is being scheduled onto the CPU. It is being scheduled onto the CPU. So by holding the CPU, what this PL process is doing? By holding the CPU, what this PL process is doing? This PL process is entering into critical section. It is entering into critical section. By holding the CPU with it, it is entering into critical section. So now, low priority process is having CPU plus the same low priority process is entered into the critical section. So while this activity is going on, a higher priority process is arrived into the ready queue. Let's say PH process. PH, what is the meaning of PH? High priority process. PH means high priority process. So a high priority process is entered into the ready queue. You know that according to the process scheduling algorithms, right? According to the process scheduling algorithms, while a low priority process is in execution, if any high priority process is arrived, then what we should do? We should hand over the CPU to the high priority process and we should add this PL back to ready queue. So now we are handovering this CPU to high priority process. And this PL is again came to, right? The PL low priority process is arrived into ready queue. Because CPU is being prevented, right? So CPU is being preempted from the low priority process. So now low priority process is in ready queue, high priority process is on the CPU. But according to the critical section problem, how many processes can be entered into the critical section at any point of time? Only one. Already critical section, as part of the critical section, we are having low priority process. Already we are having low priority process in the critical section. But the CPU is with which process? High priority process. Now this high priority process is asking this low priority process. What it is asking? I am having high priority, let me enter into critical section. But what this low priority process is telling? According to the synchronization, inter-process synchronization, or else according to the critical section problem, only one process is allowed to enter into critical section. That already I am entered into the critical section. So if you want me to come out of the critical section, I have to finish my critical section part, then I need CPU. But the CPU is with you. The CPU is with you. How can I come out of the critical section? I have not finished my critical section problem, right? I have not finished my critical section part. If you want me to come out of the critical section, I should finish that critical section part. For finishing of that critical section part, what I required? CPU is required, but the CPU is with you. So I cannot come out of the critical section, right? So, and that too, it is in the low priority process in ready queue. So now what is going on? If this PL, low priority process, if it wants to come out of the critical section, it needs CPU. Yes or no? It needs CPU. And this PH, it wants to enter into critical section, then obviously this PL should be out of the critical section. What does it mean? PH is waiting for PL to come out of the critical section. Correct? PH is, if it is interested to enter into critical section, PL should be out of the critical section. But when this PL can come out of the critical section, when this PL got the CPU. When this PL got the CPU. But PL, according to the process scheduling algorithms, when a high priority process is arrived, the CPU should be handed over to high priority process. That is being done. According to the critical section problem, only one process is allowed to enter into critical section, already it is there. Now this PH, which is high priority process, is waiting for PL to come out of the critical section, but this PL is waiting for PH to leave the CPU, because the PL is in where? Ready queue. PL is in ready queue now. By staying in the ready queue, it is entered into critical section. It is part of the critical section. And this PH is on the CPU, or else the CPU is with the PH. So obviously this is not called a lock or not. Obviously this is called a lock or not. Is it called lock or not? Yes, this is a lock. But what lock it is? Is it called deadlock? No. What is the meaning of deadlock? What is the meaning of deadlock? Deadlock means processes are blocked, they are in blocked state, right? Processes are blocked, that is what the meaning of your deadlock. But here processes are in ready state as well as in running state. Mind this, processes are in ready state and running state. But in deadlock, nobody is there in the running state. But here, somebody is there in running state as well as in ready queue. So this is called, of course it is a lock, but this is called not deadlock, this is called live lock. This is called live lock. And this is what the meaning of priority inversion problem. So the priority inversion problem is saying that if it wants to come out of the critical section, this PL needs the CPU, but the PL is having low priority. When it comes out of the CPU, when it comes out of the critical section, when this PL can come out of the critical section, when it gets the CPU. But the CPU is with the high priority process, correct? So this high priority process wants to enter into critical section, but it is not able to come out of the critical section, right? This PL is not able to come out of the critical section. So both are permanently locking here, but this is a live lock, but not deadlock. So when this kind of priority inversion is there, then what is the solution that we have to use? Priority inheritance we have to use. Priority inheritance we have to use. So what is this priority inheritance is telling that while this low priority process keep on waiting in the ready queue, at some point of time its priority gets increased. You know that the aging concept, right? The priority inheritance, it is keep on waiting in the ready queue so that at some point of time its priority gets increased. Once its priority gets increased, at some point of time the low priority processor priority is going to be higher than this higher priority process. Then obviously as it is highest priority process compared to this PH, because its waiting time is being increased, so that its priority is also increased. At some point of time comparatively this PH might be this PL is going to have highest priority. Then obviously what will happen? CPU can be removed from the PH and it will be handed over to PL. So then PL already in critical section, now it got the CPU, now PL can finish its execution and then it will come out of the critical section, then PH can enter into CPU as well as it is going to enter into critical section so that it is also able to finish. So this is called your priority inheritance. Are you clear with this point? So I hope you are clear with this priority inversion. So now based on this discussion, what is the answer for this question? If you check, priority inheritance protocol is used to prevent the priority inversion and ensure the fairness allocation in the resource, which is option C is the answer for this question. Option C is the answer for this question. Okay. So I hope you are clear with this. So priority inheritance is not allowing the process or else threads to access any resource simultaneously. No, right? So now coming to next question. So option C is the answer for this question. Look at this question. What is the answer for this question? This is from memory management. Try to go through this question and let me know what is the answer for this. So please give me the answer. If you are able to answer to this live in live chat, please answer to this question. So as part of segmentation, memory allocation strategy, right? As part of segmentation memory allocation strategy, which of the following assigns the segment number for various segments of a program like code segment and data segment? So you know that when a process is being entered, when a program is entered into main memory, then it is called process, right? So when it is being entered into the main memory, some main memory space is given to that process. That main memory space is being divided into 4 parts like code segment, data segment, correct or not? You can say that text section or else code section, data section, heap section and stack section. So this is what done by your compiler basically. But allocation of the segment number, the question is clearly mentioned that assigning the segment number, who can do that? So the segment number allocation can be done by your loader while it is loading those segments, those parts, which parts you are having, that code segment, data segment, heap segment, these things are being by the time of loading, right? So it is assigning the segment number, plus it is also assigning the starting address of the segment, which is called your base register or else relocation register. So you know that as part of the segmentation, we are using the segment table. That segment table entry contains limit and base registers. So those values are being assigned by your loader. Hence, option C is the answer for this question. So for example, if you consider here the meaning of assembler, assembler is what it is doing, just it is converting, converting your code into some mission level language code, but it is not assigning any segment number or something to your code. Linker is what it is linking all your object files together and creating some exe file, right? But it is also not assigning any segment number here. Then what is the meaning of compiler? Compiler is what it is converting your source code into object code, right? So that is also not assigning any segment number to this data section and code section or else heap section or else stack section. So basically just dividing that process into segments, but segment number can be allocated and the base register value can be allocated, or else into the base register the starting address of the segment can be saved by your loader. That is why loader is the answer for this question. I hope you got it right, Mr. Venkatesh. Right. So now let us move to the next question. So look at this question. It is related to your producer-consumer problem, which is inter-process synchronization related. In a producer-consumer scenario, also called as bounded buffer problem, what would be the most appropriate synchronization primitive to ensure that the consumer waits when the buffer is empty? Option A is a spin lock. Option B, it is mutex lock. Option D, it is monitors. Option C, it is semaphores. So can anyone please let me know what is the answer for this question? People who are part of session, please reply me. What is the answer for this? Durga Prasad, Lohita Reddy, Venkatesh, if possible, Aniket, if possible, try to answer to these questions. So spin lock is what? Basically spin lock, it is a problem in your semaphore, right? It is a problem in the semaphore, which is also called as busy waiting process, correct? So this is different aspect. Busy waiting process in the context of semaphores, it is called spin lock. So obviously this is not an answer for this question. So coming to the mutex lock, if you consider, the mutex is actually providing you what? The mutual exclusion access of the buffer. It means while producer is accessing the buffer, consumer is not allowed to access. Similarly, while consumer is accessing the buffer, producer is not allowed to access. For that purpose, we use mutex, but that is not going to be used for the consumer waits when the buffer is empty. No, right? So this is not the answer for this question. This is first for mutual exclusive access of the buffer. It is used for just for mutual exclusive access of the buffer. Next, if you consider monitors, basically monitors is used for what? It is an inter-process synchronization. It is an inter-process synchronization solution, right? You can say it is called programming language based solution. But what is the perfect answer here? Semaphores. So we are using a semaphore. So you know that in producer consumer problem we have spoken about some semaphores called empty semaphore, full semaphore and mutex semaphore. Using these three semaphores, we are able to synchronize both producer process and consumer process in the context of semaphores, right? So that is the way how we have defined. So an answer for this question is option C here. So let's say if you consider full is equals to n and empty is equals to 0, then what is the first instruction that is going to be part of your consumer process? Obviously it is going to be weight of empty. So if you make it, this is the first instruction as part of your consumer body, then empty is already 0, now you are trying to perform weight operation which is going to be unsuccessful. So that the consumer is going to be stuck in the weight operation itself, so that it cannot access the buffer when the buffer is actually empty. So this is what the explanation for this question. Option C is the answer for this question. So I hope you are following me, and listen to this next question. Yes, what is the answer for this question? Please verify. So any attempt by a process to access memory allocated to OS or process of other user results to what? What is the answer for this question? If anybody is there, please respond to this question. Any attempt by a process to access memory allocated to OS or process of the other user results into what? So option A, it is mentioned that trap to OS. Option B, it is mentioned that context switching. Option C, it is mentioned that page fault. Option D, it is mentioned invocation to scheduler dispatch. What is the answer for this question? Can somebody please answer to this question? So obviously the answer for this question is good. So the answer for this question is option A. Very good. So you know, we have discussed about a concept called, in our classes we have discussed about a concept called memory protection. Do you remember? Or else you can say memory protection, one concept is being covered, right? So memory protection is done by two registers. What are the two registers? One is called limit register and another one is called base register. Do you remember it? So whenever you have, whenever the CPU generates some logical address, whenever the CPU is generating some logical address, this logical address you are comparing with what? Whatever the limit value you are having, with that limit you are comparing this logical address. So for example, if this logical address is less than this limit value, then what you are doing? You are concatenating this logical address with base value, with the base value. Then whatever the result that you are getting, that is what your physical address. Correct? So for example, if this logical address is more than this limit value, then what you are doing? You are generating trap. So this is what the hardware circuitry that we have discussed as part of our classes with respect to memory protection concept. So how the memory can be protected using this limit and base register value. So in this example, if you consider this is what my main memory, and assuming that my process size is 1024 bytes, if you consider, then my process is been occupying from 1000 to 2023 number of addresses. So now starting address of the P is 1000, so that in base I can have 1000, and limit means what? It stores the range of physical actual addresses that are being occupied by the process in the main memory, means it is occupying how many number of addresses? 1023 or else 1024 number of addresses it is occupied. Now assuming that a 500 logical address is being generated by the CPU, then this 500 is comparing with this 1024, which is true, so that this which is true, right? So 500 is less than 1024, which is correct. So that the 500 is coming to this base. Now this base value is 1000, so that which is 1500 is the logical address, and this logical address 1500 is the physical address, which is a valid physical address because this 1500 is available in this range. But for example, if 1500 itself, let's suppose if 1500 itself it is a logical address, then 1500 is less than 1024, is it true? No. Then what is generating? trap. It means you are trying to access some other process instead of this process. That is what the explanation for this question. I hope you are clear with the explanation of this question. Is it so? Right. So let's move to the next question. Look at this question. What is the answer for this? This is a very fundamental question. I can say it is from your introduction to operating system. Try to attempt. So we need to check whether which statement is true, which statement is false. Simple. What is the answer for this question? If you are here, please respond to me. So look at this statement 1. Virtualization facilitates multiple OS simultaneously on the same hardware. Is it correct or not? Yes, it is true, no doubt, it is true. How you can say it is true? Because you know, your laptop may have Windows operating system. Now what you do, you install either VMware or else you install VirtualBox in your laptop. After installing that VirtualBox or else VMware, using this VirtualBox or else VMware, are you able to create some virtual machine or not? Yes. In that virtual machine, I may have Linux operating system or not? Yes or no? So that is the way virtualization facilitates multiple operating systems simultaneously on the same hardware, which is correct, right? Because once I install the virtual machineWare or else VirtualBox in my system, whatever the virtual machine that I am going to create, that virtual machine may contain another operating system rather than my base operating system, which is my Windows, right? Because my host system is having Windows operating system, but my virtual system may have Linux operating system. So two operating systems are being simultaneously utilizing on the same hardware. So that we can say it is a true statement. But when it comes to in second statement, in dual booting, multiple OS can run simultaneously. Is it true? No, right? It is false. How it is false? Because when you are booting, in any system you can able to boot only one operating system at a time. You may have several operating systems in your system, but it will ask you to select one operating system, then that operating system only going to, that operating system is going to boot, not both the operating systems at a time, right? Only one operating system can be booted. So that is why we can say statement 2 is false, so that option A is the answer for this question. Next, look at this question. The operating system and the other processes are protected from being modified by an already running process because. So the question is clearly mentioned, the operating system and other processes are protected, this is what the keyword. Protected from being modified by an already running process because what? Same question, whichever we have already solved. Memory protection is done by whom? Limit and base register values. So verify among the options, every address generated by the CPU is being checked against the relocation register and limit parameters. The same answer, right? So this diagram itself, the answer for this question. So option D is the answer for this question. Because memory protection is being done with the two registers, that is limit register and base register, which is also called as your relocation register. So option D is the answer for this question. Great. So now we are moving to next question. Look at this question. What is the compaction refers to? Please let me know what is the answer for this question. Compaction. You know that compaction means what? Process of bringing all free chunks at one side of the memory. Process of bringing all free memory partitions. Process of bringing all free memory partitions at one side of memory. And maximum number of processes at another side of memory. So this is what your definition for compaction. And what is the purpose of this compaction? It is used for overcoming the external fragmentation. It is a solution for external fragmentation, which is exactly option C is the answer for this question, right? So good, OG or so Sura, right? So very good. So now let us move to the next question. Look at this question. An aid to determine the deadlock occurrence. Deadlock occurrence means you can say defining the deadlock or describing the deadlock. Among the options, which is the correct answer? You can easily answer to this question. What is the answer for this question? It is the aid. It is acting as an aid, a tool to determine the deadlock or else to define the deadlock. What is the answer for this question? So are we have any starvation graph or inversion graph, some kind of stuff? No, we are having only one stuff called resource allocation graph and wait for graph. Resource allocation graph is used for defining the deadlock or describing the deadlock. Defining or describing the deadlock. Right? But when it comes to wait for graph, if you consider, wait for graph is used for deadlock. Wait for graph, it is used for deadlock. We are having two things now. One is deadlock detection, one is for wait for graph, another one is resource allocation graph. So deadlock detection, for detecting the deadlock, wait for graph we are using, right? When all resources are having single instance, by the time we are using wait for graph to detect the deadlock. So option A is the answer for this question. Good. So now we are moving to next. Look at this question, dispatch latency. So what is the meaning of this dispatch latency? Dispatch latency is also called as your context switching time. So what is the definition of context switching time? The process of loading the context of one process and saving the context of another process. So according to that, if you can check, option C is the perfect answer for this question. Okay, right. So, and might be this is the last question that we are having. Which of the following algorithms defines the time quantum? This is also straight question, right? So round robin is a time shared systems based algorithm. Time quantum is being defined only in round robin, which is suitable for time shared systems in which your processes are sharing the CPU with respect to time. So that round robin is the answer for this question, straight question. So these kind of questions are there in our previous year of 2023 as well as 2020 as part of our ISRO papers. I hope this discussion is helpful to you. All the best for your ISRO examination, right? Thank you so much.